In this PowerPoint, we'll be covering how to solve two-step equations. So this is a next step past solving one-step equations. We're going to be using all the four properties we've talked about. The equality property of addition, subtraction, multiplication, and division here. So just like the name states, we'll be using two steps to solve for our variable instead of one. So we have some steps here. Our first step is to get rid of the number that's not connected to our variable. And in this step, we're going to be undoing either addition or subtraction, depending on what the original problem is saying. So what it states in the very beginning. If it's using addition, we'll use subtraction. If it's using subtraction, we'll use addition, just like our one-step equations. Once we've done that, our second step is to get rid of the number that's connected to our variable. And the way we do this is either undoing multiplication or undoing division, using the opposite or the inverse operation. And then again, our last step will always be to check our answer. So we will use our check step here as well. And our check step will be at least one step longer than our check steps in our one-step equation. So our first example here is 2x plus 12 equals 4. We're going to draw those same railroad tracks. And our first step is to get rid of the number that's not connected to our variable, which here is a positive 12. So to undo this addition, we're going to subtract 12. And our property of equality, we're going to subtract 12 from the right side as well. Those 12s on the left cancel out, and we're left with 2x equals 4 minus 12, which is negative 8. Those are those integer rules that are going to come back. Now, our second step says to get rid of the number that's connected to our variable. So here it's a positive 2. It's 2x, or 2 times x, so we're going to be using division. We're going to divide by the number connected to our variable, which is 2. So we're also going to divide the right side by 2. Our equality property of division. Those 2's cancel out on the left side, so we're left with x equals negative 4. Box side answer, but to make sure, again, we do our check step. So we always start with our original problem, which is 2x plus 12 equals 4. Our next step is to plug in what we believe that our value of our variable must be to make this equation true, which is negative 4 plus 12 equals 4. Now in this step, we're using our order of operations, parentheses, exponents, multiplication, division, addition, subtraction. Now normally, it's going to be multiplication, division, addition, subtraction. So here, we're going left to right. We multiply first. 2 times negative 4 is negative 8 plus 12 equals 4. Negative 8 plus 12 is 4, so 4 equals 4. So we know that x does equal negative 4. Our next example, we have 3, quantity x minus 4 equals 9. I'm going to draw, again, these railroad tracks. I'll do these on every problem. And what we're going to do here, instead of starting, we see this set of parentheses. We're going to use our distributive property. And we're going to distribute that 3 to both the x and that 4 inside our parentheses. So 3 times x is 3x minus 3 times 4, which is 12. Bring down our equal sign and bring down our 9. So now this looks like a regular two-step equation. We're going to get rid of what's not connected to our variable, which is a negative 12. So we're going to add 12 to the left side, and we're going to add 12 to the right side. Those 12s on the left cancel out. We have 3x on the right side equals 21. Now we need to get rid of the number that's connected to our variable, or our coefficient. We're going to divide by 3, because we started with multiplication here, so we want to do division to undo that multiplication. Those 3's cancel out, and we're left with x equals 21 divided by 3, which is 7. Again, to make sure this is right, we're going to do our check step. Now here it's important to use our original problem. If we did the distributive property incorrectly, then plugging in our answer wouldn't do us much good, so we're going to start with our beginning problem. 3 quantity x minus 4 equals 9. And then our next step is to plug in what we say our x is, which we say 7 here. So 3 quantity 7 minus 4 equals 9. Again, those order of operations, we're going to do what's inside the parentheses first. So 3 in parentheses 3 equals 9. When a number is next to another number with parentheses around it, that is just multiplication. So 3 times 3 is 9. 9 equals 9. So we're right on this one as well. X equals 7. This is our final answer. We now have m over 2 plus 6 equals 10. So I'm going to draw my two lines. Now we're starting with getting rid of what's not connected to our variable. So here it's a positive 6, so we're going to subtract 6. We have m over 2 equals 4. And now here this is division, so what we want to do to undo division is multiplication. And we're using the number that's next to our variable, or on the side with our variable. So here we're going to multiply by 2 over 1. Here we're going to multiply by 2, or 2 over 1, same value. These 2's cancel out, and we're just left with m equals 8. To make sure this is right, go to our check step, write our original problem, m over 2 plus 6 equals 10. Our value for m we say is 8 over 2 plus 6 equals 10. 8 divided by 2 is 4 plus 6 equals 10, and 10 does equal 10. So we're right on this one as well. Our last example problem here, we have 3 terms on our left side of our equal sign. So here first, we're going to combine our like terms. So if we were to look at this like 3 separate terms, we can combine our constants together. So 4 plus 3 is a positive 7 minus 2y equals negative 9. So we have a positive 7 here. To undo that, or to get rid of that, we subtract 7. Subtract 7 from both sides. We're left with negative 2y equals negative 16. Then we're going to undo this multiplication on our left side and divide by a negative 2, so we're left with a positive y. And so we divide our right side by negative 2. These negative 2's cancel out. We're left with y equals a positive 8, because a negative divided by a negative is a positive. Again, we're going to make sure that answer is correct. Start with our original problem, 4 minus 2y plus 3 equals negative 9. So we're going to plug in what we find our y to be. So we're going to plug in 8 for y, negative 9. We have 4 minus 16 plus 3 equals negative 9. Now here we have to really make sure we follow our order of operations. We have to do this subtraction first, because that comes first from left to right. So 4 minus 16 is negative 12, plus 3 equals negative 9. Negative 12 plus a positive 3, we're going 3 in the positive direction if we're thinking of a number line, and we should have a negative 9 equals negative 9. Now these are our last working out examples. So we've gotten all those right. We did all of our check steps. We have one last thing we want to point out. I want to describe and correct the error in finding the solution. So this is an example problem someone did, and they ended up with the incorrect answer. So if they would have done their check step, they would have seen that x does not equal negative 3. So if we think about this here, negative 3x plus 2 equals negative 7. We're actually going to work this out to find their error. We first get rid of this positive 2 by subtracting 2. Subtracting 2, negative 3x equals negative 9. So right now, they've done everything correctly. Now we need to divide both sides by negative 3, because that's the number that's connected to our variable. Here is where we find the error. They're dividing both sides by a positive 3. So really, we are saying negative x equals negative 3, but we want a positive x. So we should have positive x equals 3. So our final answer should actually be 3. And to make sure we got that right, we could plug this in to our original problem to make sure it is correct. We say that our x should be a positive 3. So when we do negative 3 times 3 is a negative 9, plus a positive 2 equals negative 7. Negative 7 equals negative 7. So here they divided by a positive 3. They didn't take the number that was connected to our variable. They ignored the sign. So that's where they found their error there. So this YouTube video was to cover how to solve two-step equations with a few examples. So hopefully you guys understand this and you'll be able to solve all two-step equations from now on.